Well, welcome, ladies and gentlemen, to Aqua Metal's channel, reinventing metal recycling with its patented hydrometallurgical aqua refining technology. And joining us to give us a high-level overview of the business today through the investor presentation, we have President and CEO Steve joining us. What a privilege! Thanks so much, sir, and welcome.
Thank you. Great to be here.
It's our pleasure. So I'm going to hand the reins over to you to kind of just walk us through this.
Great. Okay. So I'm going to be providing some information here on Aqua Metals, starting with this opener slide where you see in the background our pilot and demonstration plant for lithium-ion recycling that exists in Tahoe Reno Industrial Center, which is truly leading a revolution in what we call clean metals and battery recycling, and we'll explain why. So here's our standard public company disclaimer that you can read in your own time. And let's start with the investor highlights. So Aqua Metals has a very highly patented recycling solution and patent pending solution that has the potential to deliver what we believe are the best economics and the lowest environmental impact for closing the loop and truly managing the recycling of lithium-ion batteries. So a little bit about lithium-ion and lithium-ion batteries is we know in the left column that there's a surging demand. EVs, mobile devices, solar, everything that uses batteries is driving demand growth. But there's a battery component deficit where there's a lot of these critical battery minerals to drive the electrification of transportation and other parts of the economy. And currently, Asia is really controlling the marketplace. And North America is standing up a whole industry that I'll tell you more about. If it's done wrong, the standing up of the industry, particularly the closing of the loop and the recycling of these critical battery minerals that get mined, get used, and then ultimately need to be recycled, we would have an environmental disaster. And we're going to talk about the environmental impacts of recycling and how Aqua Metals compares to the other methodologies. So we are a pioneer in sustainable lithium battery recycling, and that is essential for the clean energy world that is in this rapid market growth. And we are taking our innovative technology called Aqua refining and deploying that at a commercial scale, targeting commercial quantities of production beyond what we already are doing in our pilot and early demonstration plant, and getting to that commercial production in 2025. If you look at the overall market potential, there's over 1.2 terawatt hours of battery manufacturing expected in North America alone by 2030. And I'll show you a map of that that shows how we're standing up one of the biggest industries since the railroads and interstate highways. There's a closed loop ecosystem that's developing, and we're partnering with leading companies in battery manufacturing materials, as well as vehicle OEMs who have verticalized into that space to produce low carbon and incentive eligible battery materials domestically for the first time. So here is an idea for everybody to look at on the rapid expansion of the North American battery industry. You'll see all the dots on the map where there's vehicle assembly locations that are taking place throughout North America. There's by 2030 going to be enough production to support 16 million electric vehicles each year, $92 billion of total investment counting to build all the gigafactory battery manufacturing to support all the vehicle manufacturing facilities. And there'll be 80 plus processing and manufacturing facilities that all need lithium, nickel, and cobalt to develop and deploy all these stored energy and EV battery applications. The supply chain for lithium batteries is growing rapidly throughout the country and North America as a whole, and is creating immense demand very quickly for these critical minerals that require significant new battery end-of-life and recycling infrastructure. And that planned build-out is going to produce more material for recycling than processing capacity. Therein lies an opportunity. This is a little bit more information on the speed with which we're seeing the growth of materials that is coming from these gigafactories, as well as from end-of-life batteries. And you'll see in 2020, there was just 0.1 million tons of materials, about 50-50 split from gigafactory production versus post-consumer scrap, used batteries that have served their lifespan, be it an iPhone all the way up to an EV. And then if you look at 2025, 30, and 35, you can see the rapid progression to over 1 million tons of materials that will become available for recycling. Particularly 2025 and 2030, you'll see that a lot of that material comes from the global post-consumer scrap and the global post-industry scrap, which is also known as the gigafactory scrap materials, which becomes a significant percentage again as those gigafactories really ramp up and begin producing for the hypergrowth that we'll see coming soon. So therein lies the opportunity to find ways to produce these materials for these suppliers through a clean recycling method. We have the next generation recycling process. We recover the high value metals. We do it in a very safe working environment where people want those jobs, where they have to wear lab coats and glasses for safety, as opposed to chemical suits and hot suits that you'll see in other processes. We're the only recycling process that natively produces lithium hydroxide in our process, and we can also produce lithium carbonate from that lithium hydroxide to have two lithium products. And we regenerate the chemicals that we use in a closed loop versus one-time use chemicals, and we drive the process with electricity. So we believe that our technology has a path to net zero operations in terms of emissions, which is highly valued by all those global OEMs as accretive to their net zero efforts. We have very strong IP protection, as you'll see in the lower left, with 73 global patents and 43 patents that are pending. We have our proven pilot operations that have been running for over a year, which have demonstrated our ability to run lithium AquaRefining at a scale that we know we can take to commercial quantities in 2025 with our Sierra Arc facility, which I'll be showing you pictures of here shortly. We replace furnaces, we replace heavy chemical use, we drive our process with electricity, and we generate very little CO2 and very minimal waste. So if you look at legacy processes, they really just are not sustainable. If you look at pyrometallurgy, you'll see a picture in the upper left that shows what you have to wear and what it's like to work in a smelting process for battery recycling. And it's not a pretty picture, and it creates not only worker safety issues, but lots of CO2, lots of waste streams, and lots of danger for those workers, and less favorable economics because you will not be able to salvage much of the lithium, if any, as well as the manganese and graphite is very difficult to recover. If you look at next generation hydrometallurgy, it's a great idea, but it still requires a tank farm of epic proportions, truckloads and trainloads of one-time use chemicals showing up every day, a bunch of people to manage all that CapEx infrastructure in an operating environment, inclusive of, on the back end that you'll see on the right, massive crystallization methods that consume tons of energy and expense to create sodium sulfate at a quantity that is sometimes more than the material being processed. And that is what you need to eliminate in order to have truly sustainable recycling. And with Aqua Metals, AquaRefining eliminates all of these challenges. So this is a little bit more of a drill down of the pyrometallurgical compared to hydrometallurgical compared to AquaRefining. And you'll see the differences between these processes. And I'll just highlight that with AquaRefining, we produce all these materials that you see, the cobalt, the nickel, and the copper in a metal form. We make the lithium in the form of lithium hydroxide or carbonate, both of which is like a white powder form. And then we produce the manganese in the form of manganese dioxide, which could go right back into the battery industry. We are unique that we drive that process with electricity. We regenerate the chemicals, and we do not have partial recycling. We have full recycling. And we could take those metals that we produce in metal form and also sell them into the metals markets, as well as, of course, closing the loop in the batteries markets. And that very much de-risks our revenue opportunities as a company. So this is how the closed loop reduces the waste streams by 95%. You'll see that we regenerate the chemicals in our lithium recycling loop and go back and absorb that black mass, which is the precursor feedstock material for us, which is crushed batteries or feedstock from gigafactory materials. And we produce all these materials and regenerate the chemicals using electricity, resulting in 99% less CO2 or greenhouse gas than pyro or mining, and no polluting furnaces, and 95% less chemicals than hydrometallurgical processes. And our regenerative process lowers all those costs while lowering the environmental impact dramatically. Not significantly, but dramatically. 95% plus recovery rate is also really important for yield for all those valuable materials, so we can generate the right economics to make this a profit-producing venture. So this is the game-changing environmental and economic performance comparison. If you look on the left at the pyro and hydro, this is the amount of CO2 that's produced per ton of black mass that's recycled. With pyrometallurgical in the red there, you'll see that pyrometallurgical processes make 4 times the weight of the gas of the CO2 that goes into the air as greenhouse gases than the material being recycled. Totally and completely unsustainable. The hydrometallurgical process reduces the CO2 because instead of burning things, it's chemical reactions, and you can't scrub CO2 away, and makes almost 3 times the weight of CO2 gas. Also unsustainable. We may as well stick with oil and gas if we use those processes. If you compare that to aqua refining, it's very de minimis and makes sense from a CO2 impact perspective and a greenhouse gas and decarbonization perspective. We are decarbonized. And again, that's because we drive the process with electricity. It can be renewable electricity, and we don't generate any CO2 from our process. And as long as the electricity that's driving it is clean, we're as clean as you see right there. Sodium sulfate, in terms of the solid waste that I was mentioning earlier, you can see the comparison between pyro, hydro, and aqua refining having none, and all the costs and environmental impact and worker safety issues are completely eliminated with our process with better economics. This is what our pilot plant looks like in Tahoe Reno Industrial Center, which currently has a capacity between 75 and 100 tons per year that we've been producing battery grade materials and sharing with various OEMs. As you can see, the gentleman in the background, the working environment is a job someone actually wants, which is that you're wearing a lab coat and safety glasses and working in a comfortable, temperate environment that allows you to really have a 21st century job of sustainability as compared to some of these other processes. The sustainable lithium pioneering that we're doing is what we believe electrifies the next generation of battery recycling and lithium battery recycling. In the left picture there, you see what our nickel plating mechanism looks like from our what we call aqualyzers or electrolyzers that generate that nickel quietly and safely and efficiently. And then on the right, you'll see our Vice President of Engineering, Jim Kenny, looking down some of our plant production area, which includes some solvent extraction to make the concentrates that ultimately go into those aqualyzers to allow us to plate those metals and those materials. We're electrifying the next generation of recycling with our electroplating techniques, our ability to deliver various cathode active material, battery manufacturers, materials that they can get into specification and produce end materials that close the loop fully. And because we produce metals in metal form, it's valuable not only to the battery industry, but multiple industries, and at 5 times less cost shipping metals from a location such as the Sierra Arc to other locations that require this versus wet materials that are in salt form that take much more truckload capacity. So it helps to decarbonize, but also it helps reduce the logistics and costs associated with it. Also, it's important to note that our partner Dragonfly Energy has already produced lithium cells and successfully cycled them from our recycled product, which we believe is a first in the North American battery industry, which is very exciting that we've been able to partner with Dragonfly Energy, which is also Tahoe Reno based, and producing next generation lithium ion batteries using recycled materials such as ours. So if you look at a deeper drill down on the recycling operational analysis, we had a third-party international engineering company called ICF that evaluated and showed that the process electricity is really the only thing that's generating the carbon in our process. And when you go with net zero aspirations and go with clean electricity, you can eliminate that carbon from the process electricity and truly have a net zero pathway. This is the Sierra Arc. This is what we have in the lower right today is an existing building that we've already upfitted and is move-in ready with the equipment, and we expect to get that into production in 2025. And then you'll see the other two buildings in the upper left and in the rear that we intend to build on that 5-acre campus to get to 10,000 tons per year, or about 100,000 EV battery packs per year of recycling capacity for North America, driving that critical minerals recycled materials growth. The Sierra Arc has been through lots of upfitting to prepare this building for the equipment that's being delivered and get to that full campus environment by erecting those additional two buildings. But the building is ready for the final equipment installation and commissioning. So we're really excited about the progress we've made in 2024 to get this existing building in a condition to be such a wonderful recycling center, phase one. On business partnerships, we have a partnership with a company called 6K Energy, and 6K Energy is a cathode active material producer that can beat China at its own game and produce cathode active material with an electrified, decarbonized process at a significant cost advantage, inclusive of our technologies that help enable 6K Energy to help close that loop and get that into the battery loop, battery materials that are now recycled. And can provide that together as two companies really supporting the cathode active materials that go to the battery manufacturers that then go into new batteries. 6K Energy has a facility, as you see in the lower left, that they're building in Jackson, Tennessee, called Plus Cam, that we are already in work with them to be a strategic supplier of materials to that facility, and potentially co-locating another ARC in the Jackson, Tennessee area adjacent to make the efficiency even better from co-location opportunity. We're also working with 6K Energy on a technology that we've developed to create nitrated metals, both from recycled and from mine supplies, to enable 6K to be North America's leading producer of cathode active materials and put North America on the map as a producer. We also have a partner that invested in Aqua Metals, you'll see in the middle, called Yulho. Yulho Materials is enabling their black mass production facility by collecting batteries, producing the black mass, and has intent, as they turn that facility on later this year, to work with us to finalize a licensing agreement where they will build an ARC very similar to the Sierra Arc south of Seoul in Hwaseong in South Korea. And so we're very excited about the ability for our business model to support licensees and propagate our technology with reduced CapEx to complement our build, own, and operate plants. I mentioned Dragonfly Energy earlier, who's building a lithium next generation silicon anode dry deposition lithium solid state batteries in the form of lithium iron phosphate and cobalt and nickel free. And as a future supplier of lithium to Dragonfly, we're very proud of that partnership and relationship that we have with them to be a very strategic and local off-taker for us right here in the state of Nevada. Here's our commercial scale timeline as we finish commissioning the plant in 2025 and start to produce materials and get into revenues late 25 into 26. And then the revenue growth as we ground break the phase two, those additional two buildings I showed you pictures of, the Sierra Arc, and getting to that 10,000 tons per year of produced material and generating quite a bit of revenue from our operations. Financials for the company. As of June 30th, our last financial reporting period showed cash and cash equivalents of $7.8 million, total assets of $33.7 million, and a quarterly burn rate of about $1.5 million, starting as we enter Q4 of 2024. Additional sources of capital the company is currently seeking to facilitate the build out of the entire Sierra Arc campus facility is inclusive of project financing. Up to about $85 million is targeted to complete the build out. Non-dilutive short-term financing, we've got about $25 million targeted, with potential asset-backed equipment financing of $4 million. So the company is well positioned to support both the short and the longer term sources of capital in as non-dilutive of a method as possible to facilitate getting the company into those revenues and producing EBITDA. Here's just a short quip on the management team. You can read all about us, but just note that we're from the battery industry and the metals and mining industry with cumulative many decades of experience And so we know what we're doing, and you can read all about us on LinkedIn and on our website. So again, to conclude with those investor highlights, our patented process addresses the surging demand, the battery component deficit here in North America, and averts an environmental disaster. And we are very proud of our Aqua refining technologies and look forward to engaging with investors who have questions and are welcome to come and visit our pilot plant facility. It is not a black box. People can come and take a look. And there's plenty of materials on our website with videos, video walkthroughs, just like is almost as good as being there. So you're welcome to take a look and review all the materials that we have in depth on our website to learn more about Aqua Metals.